So I'm going to go through very quickly the 2009 preliminary exam. And the reason I'm going to do that is I'm just going to say which questions I like and which questions I don't think are really likely to be tested by me. Now, so question 1 says, which one describes voltage? That's a good question. It's the sort of thing I would ask. Now, can anyone give the definition? What is the quintessential definition when we ask what's the definition of voltage? Potential difference between two charges, or the potential difference in a circuit. The idea that when we have a battery, one side has a lot of positive charge, the other one has a negative charge. The difference between those two charges is going to have it's going to be a representative of how much electromagnetic force is going to push electrons or charged particles through a circuit. That's a good question. All right, so the resistance to flow, well, obviously is resistance. Value that permits... look, I'm not going to go through all the answers, right? I provided answers online, but I'm just going to go through... It's a sort of question that is definitely something that I might ask. Okay. Which is the best indicator of Young's modulus? Now, so if we have stress-strain diagrams, Young's modulus happens to be the slope of the line, or the gradient of the line, right, during its straight area. Yeah, only for its elastic range. But understanding things like the breaking point, necking, those sorts of things, they're questions that I definitely consider asking you. Okay, which statement best describes why car bodies are generally made from low-carbon steel? Okay, it's a good question. Now it says low-carbon steel is tough because it contains a large amount of ferrite. It's strong because it... Okay, so what we want to look at there is we need to know the properties of low-carbon steel. So low-carbon steel, does it have a lot of ferrite or a lot of pearlite? Does it have more ferrite or more pearlite? It's going to have more ferrite. Yeah, pearlite, we get full pearlite at 0.8%. Low carbon, we're going to have more ferrite than pearlite. Ferrite is soft, which is going to make it soft, and it's going to make it it's going to be ductile, right? Whereas if we have more pearlite, we're going to have more strength and we're going to have more hardness. Now the question is, which one is good for a car body? Right? Usually for a car body, we want something that's not too hard, or we're not interested in hardness or strength. Where strength is important, what we're really looking at more is toughness, right? And ductility, so that it can be formed is probably more important there. Okay, moving along. Asking about welding. Welding is a good question. I like questions about welding, right? So there's 4 main types of welding: oxy, stick, or shielded metal arc welding, MIG, and TIG. Right, it's a good idea to know about those. It's important to know things like why don't we weld, or why do we have to be careful when welding high carbon steel?
Why do we?
Because we can end up with martensite. Is that familiar to you? That if we weld stuff with high carbon, we can end up getting martensite, and martensite, unless it's tempered, is a problem. So we don't want to have that. So we have to be very careful when we say TIG weld high carbon steel. Okay, hierarchy of waste management. What is the most important way of dealing with waste? Design in such a waste reduction. So designing in such a way that we don't have waste reduction. Now, in the case of reuse versus recycling, generally we consider reuse to be better than recycling. That's a slightly tougher question, but it's obviously going to be between A and C, just because waste reduction, design to eliminate the problems, is always the preferable one. Okay, the second most important thing that you need to know in this subject is how to calculate stress. Stress equals force over area. Now, we're not given an area. You have to calculate the area given a diameter, but that should be within your abilities. Now, it's important that we always remember we always use newtons, always newtons. So we're going to write this as 11,310 newtons. Now, we're allowed to use millimeters squared and megapascals. If we put our answer in with millimeters, we'll get our answer out in megapascals. So that can be a convenient attitude. Now, if you want to use everything in meters squared and then get all your answers out in pascals, fine by me. But I have a song to help you remember, the Grease song, We Go Together, like megapascals and millimeters squared. I did it the wrong way around then, but that's fine. Force over area, yep, but just make sure you use the right units so that you get a sensible answer. Okay, very, very, very likely question. Okay, what is the process of normalizing steel? Good question, right? You should know what all of these are, right? Which one is cooling in air, normalizing? Which one is quenching? Yeah, quenching in water, and then quenching and then heating up again is tempering. Cooling in air, so we want to heat above red heat. But also there's another one which is annealing, which is cooling in a furnace. Okay, which statement best describes the reason why alloys strengthen metals? Another good question. Yeah, we've talked about this. We've talked about how alloys strengthen and harden, and also how work hardening strengthens and hardens. Right? They have more grain boundaries because of work hardening. Work hardening creates more grain boundaries. Yeah, but that answer would be true for work hardening. One of these here is true for alloying. Right? It's where we have additional foreign atoms which prevent slip. Okay. Now, question 9. Now, this is a question about friction. Understanding friction, what is the horizontal force? No coefficient of friction here. Okay. I think what they're trying to do is just trying to get what is the component of the force. Asking you to break up a diagonal and give me a horizontal and vertical component, very likely to be in the exam. Right? In terms of pushing, typically when I say pushing, I expect the question to be about friction. Now, a friction question at an angle, I will not give that to you at the prelim. Not this year anyway. Not in 2018. 2019, if you're listening to this, be afraid. I may well do that. Ask me. But 2018, you're safe from friction at an angle this time round. Now, what you will need to know is you will need to know F equals mu n. You will need to know how to apply that formula. Okay. Electrical appliances, yeah, that's a pretty common one. Electrical safety is part of the syllabus, right? Understanding why there's 2 pins and 3 pins. Talking about things like double reinforced, double insulated cables, right? That's something a question I could likely ask you, yeah, about electrical safety. Also, similar questions that might come up, things like calculating voltage, calculating resistance. They're questions that are very common to come up. Okay. Outline one development in household appliances. Now, we didn't focus heaps on household appliances. We've discussed this previously. But even if let's just say, for instance, you're more likely to get questions on, say, lawnmowers. And if I was to ask you, let's do the same question with lawnmowers. What's an innovation or a development, a historical innovation in lawnmowers? Petrol power? Yep, great. That's one development. Yep, okay. How did it benefit society? Efficiency, yeah. It meant that younger children and women were more likely to be able to mow lawns because it required less physical strength. Okay, how did it affect the environment? When we had push motors, there was no pollution. Whereas when we started using fossil fuels, there was pollution and there was an effect. Now, this question says benefits, right? So we wouldn't talk about that. That would not be a great one for best. But if we wanted to say a move from 2-stroke to 4-stroke, that would be an environmental benefit. Yeah, so what's the benefit? Well, it's more efficient, saves money, right? And it has less fuel, so less carbon dioxide emission, fewer greenhouse gases. Okay, here's a question on the stress-strain diagram. This is absolutely the sort of thing you might get. So, where does necking start? Necking starts from here. This is the breaking point. Where's the elastic range? Yeah. What material is this likely to be? Steel. Yep, low carbon steel. Okay, so we have the plastic zone. The plastic zone is everything from that definite yield point, right? That's everything past the definite yield point is the plastic zone. This is the elastic zone, this side here. Indication of toughness is the area under the curve, right? The higher it goes at any point, well, so certainly the higher point in the elastic range is typically what we're interested in. This is the ultimate tensile strength, right? So the higher it is, the stronger it is. The longer it is, the more... starts with a D. Ductile. Great. Yes. Just typically, so 0.3% steel is it's something we use so often that you should recognize that curve. For other things like really low carbon or brass, we get more of a progressive yield. We don't have the definite yield point. For high carbon, we're more likely to have no plastic range.
Is that where it first drops?
From here. from here past. Yeah,
Plasticity
from here is
zone
necking.
That first straight line.
Yes.
And then plasticity zone's a whole second part, isn't it?
Yes.
An indication of toughness is the whole length.
No, the whole area.
The whole area.
Yep. Okay. Now, this question here, it's a 3/4 method question. Like I said, I've told you that there will likely be a question like this in your exam, right? So, how do you solve this question? Well, there's two ways of doing it. One is that you can find the point of concurrency. So, I know that one force is going in this line. I keep going up. The point of concurrency is about there. So, that means my angle is going to be going through here. Yeah, it's going to be going, join that line to this reaction. That's where my point of concurrency is going to be. Now, if this force is going, as far as the viewer is seeing, from left to right, that means this force here is going to have to be going to the right to left. So it has to be going in the opposite direction in order to maintain that equilibrium. Now, let's just say that we didn't want to go with that. Alternatively, what we can do is we can break this force into its horizontal and vertical component. Now, very unfortunately, they're using 35 degrees. I typically won't give you 35 degrees. I'll typically give you a very convenient 30 degrees, so you can do those numbers in your head. But the horizontal component of this 10 newtons is 10 sine 35. There's also a vertical component, which is 10 cos 35. But we can ignore that, and the reason why we can ignore that is because that force is going through the pivot. Yeah, its multiplier is 0. Yeah? Does that make sense? Yeah. Now, I'll go through this question specifically as an example because this is the sort of question I had other people ask me about. But once I have that 10 sine 35, wait, sorry, I think I got that mixed up. I'm very sorry. This is 35. Sine is opposite, cos is adjacent. So 10 cos 35. 10 cos 35 times 63 divided by 35 gives me the force in this rod. Now, if that doesn't make sense, there are questions in the Copeland book. I will go through it again, but be warned, this is the sort of question that will absolutely be in the exam. Okay. Now, reaction at the pivot. The reaction at the pivot, that's a bit mean. But it's worth 6 marks. Quite a few points there, right? So the reaction at the pivot is probably worth more like 4 points. Look, it could be 3 and 3, but it's more likely that the reaction requires slightly more effort. They haven't asked for the angle, which is nice of them. They've only asked for the magnitude. Well, I mean, they haven't specified specifically the angle, and they haven't given you room to show where the angle is. So they maybe were being very kind and saying that they weren't going to take marks off for not giving the angle. Me, I will be more inclined to say specify the angle. You should always specify the angle unless it says otherwise. But just here in the marking guideline, that might be why it was 6 marks. 3 and 4 is pretty fair for that amount of work. So 7 points total instead of 6. Sorry? How many marks is it worth? It says 6. I will go through it as this is the quick version, and actually we're getting to our time. So at the end of this question, I'll restart. Explain in terms of structural changes why we work hard and when they're subjected to stress. We've already discussed that above. More grain boundaries make it harder to push dislocations through the boundary. Okay, so